Alright, so we have a string instrument, and it has a string with a mass of 40 grams and a length of 50 centimeters. And that string is plucked, traveling at 300 meters per second. And then the string is replaced with one that has 3 times the mass, but the same length, under the same tension. And we want to know what the new velocity is. Now, I've set up here 2 different methods of solving this particular problem, so don't panic that it looks like there's a lot of work. The first method over here is I've actually rearranged your equation to solve for force. And since F1 equals F2, I can say that the velocity squared times the linear mass density for 1 is going to equal velocity squared times the linear mass density of 2. And I've subbed in for linear mass density of mass over length. Since the length doesn't change, I canceled it out, which gives us this here. And since we are tripling the mass, I'm going to say m2 equals 3 times m1, which cancels out the m1, and we're left with this relationship here. So I can plug in the first velocity, square it, divide by 3, take the square root, and get this number here. So 173 meters per second. The other way to do this is to use our initial relationship here, and I've calculated the first linear mass density, and I encourage you to do it in a separate step. It's really easy to not get the fraction in your calculator correctly and end up with the inverse of the linear mass density in there. So I first calculated my linear mass density, I plugged in the 300, the linear mass density, and my tension is equal to 7,200 newtons. I can then sub that 7,200 newtons back in with the new linear mass density, where my mass is 3 times the original, which means the linear mass density is 3 times what it was because the length hasn't changed. And I can sub in and get my new velocity.